Welcome back to the stream, folks. We are live on a weekend, which is always nice. It's something I should do more often. So this will be a continuation of the thing we've been working on for the last couple days, which is basically a silly robot, which is a pretty self-contained project, but I'm trying to develop it into something that I can turn into a little article or something that's easy for people to reproduce on their own. So the basic idea is that it's a robot that skitters around on little vibrating motors in a fairly random fashion, but then we use kind of a hacked graphics tablet, which is kind of where it ties into, like, I want to show people kind of inspiration for how they can use sensors to create better robots, and how they can repurpose existing sensors. So yeah, easy reproducibility, better working, all that. For the moment, I think my priority is, since I did put the wireless microphone on today, maybe I can actually point the camera toward the cat and we can hang out with the Chuco cam for a sec. Where are you, Chuco? Oh, there you are. Oh, yeah. Yeah, it's been a hell of a morning for a lot of folks. Yeah, I don't know what to say about that other than this continues to be a really strange place and time to live in. Or maybe, yeah, I don't know what to say about that right now. Here's a cat. Let me maybe take on the role of carrying the camera around, since I still have not actually gotten to the next phase of this project, which is making the robot move around using the winches. Where is Chuco? Oh, there he is. There are a bunch of things we could be doing on that. I've just gotten sidetracked by some unrelated projects in the meantime. Can this follow us? Or did it lose us? It lost us. Chuco really likes this toy. I got this for him around Christmas time, and it easily causes him to move fast enough that the correlation tracker loses him with the current settings. That's one of the many things on the list of stuff to work on, is to try to get the correlation tracker to be better at tracking fast-moving objects. There are a few things I've thought of for doing that. There might be maybe another layer of tracking where we use this correlation tracker for certain kinds of objects, but then maybe there's also something that's based on just like optical flow that's better at tracking him when he gets so fast that we can't recognize him frame to frame. Since I've slowed down what happens, and I think part of the problem is that he's moving fast, but part of the problem is that he changes shape quickly enough that the correlation tracker doesn't adapt to that. So that might be a time to kind of adapt some like kind of lower level behavior, so that maybe if the correlation tracker has a bad estimate or it's just not finding him at all, then maybe we just look at the optical flow vectors in the same area, and then like that kind of seems to mirror my own experience of being an animal with reflexes. And if I don't actually see where something's going, but I can still see fast motion in a particular direction, I'll follow that fast motion. So I think maybe that's one direction to go in. Another direction to go in is just a completely different correlation tracker algorithm. I went over this in the last video if you check out the latest edited videos on scanlime.org, but the video on computer vision goes into these two separate algorithms that I'm using, where one of them actually looks for objects and detects them and puts labels on them and such, but then the other algorithm is just looking for motion. Or more specifically, it's looking for matches for a rectangular area of the image. So once we've already localized, like, here's Chuco, or here's like whatever the robot's interested in, then it can just follow that group of pixels. Sorry, my voice is getting all hoarse. My coffee is on the other side of the room. I should get that. But Chuco's right here enjoying my simulated bird company. I like to think of these feather toys as not like birds, because like birds, oh, he actually ripped off a hunk. Because I wouldn't want to see Chuco doing this to an actual bird, but just like a generic bit of like feathery prey is kind of nice. But then another option is to just imagine that this is like something else bird-like that just makes me mad. Like this toy could be a representation of all the terrible things on Twitter, and I can just watch Chuco destroy it for the more fanciful approach. Alright, I'm gonna get my coffee while Chuco's chewing on this. He gets surprised and annoyed when I let up on the pressure all of a sudden. What's going on here? Oh, Joseph, I was trying to decode Joseph's question about the frame rate on the camera. I guess you mean for tracking. No, the camera on the Flyer only does 30 frames a second. And doing like high frame rate 1080p would just be yet another tier of having to move huge amounts of data over tiny cables. Like, it's already kind of pushing it doing 1080p 30. I would just need a lot more expensive and specialized hardware to do high frame rate video. And I would also, I mean, that would also then come back to needing a better tracking algorithm. The current tracking algorithm is basically CPU limited at this point also. But when I was trying to also track scale estimation in addition to position, it was pretty much maxing out one of my CPU cores. I have it adjusted so that it's probably only using about 20% of a core. James is wondering if fear of heights is one of the limiting factors in getting the winch bots going. Well, it's part of it, but I mean, it certainly isn't the only thing. It's just like the whole like pulley installation thing is not a situation I'm looking forward to, because it basically involves one person, probably me, climbing up to the ceiling while another person holds the ladder, and the ladder itself is very heavy, and it would probably be better to have more than one person holding the ladder. And so I basically just need to have like a pulley installation party at some point, and I'm roughly ready for it. I've got to make sure I have enough rope and tie-off points, because I'm planning on so I don't know if we need to get into the whole yak stack right now, because part of it was figuring out like exactly how to do the rigging. I hadn't exactly decided exactly where I wanted to tie everything down, and I'm still not 100% of the way there, but I've got a couple of good options. Basically, I'm trying to, at this point, decide between, so I need rigging points on 4 corners. I've already got one kind of in the middle of one side that I'm using for wiring. It's not a great point. It would be nice to re-rig that one, but I'll take it for now. So I need 2 on the loft side here, which I would move the camera and show you all of these things, but that would involve taking Chuco off the frame. Maybe I can just put the DSLR on top. Yeah, actually, I don't want to bother with that right now, do I? Let me see if I'm out of fresh SD cards because I was waiting on one to copy, but that might be done by now. Now that I have the wireless microphone, I can actually check that out. Oh, it's still copying. I might have to dip into my second tier SD cards. I've got like 3 that I rotate through normally, because they're like the brand name that I currently feel most comfortable with. But I've also got some of these Lexar 64 gigs, which I had been using, but I have had a little bit of data corruption with these cards. I probably am going to have a little bit of data corruption with any brand if I use them long enough, just given how many SD cards I end up rewriting every week. But yeah, I decided to switch to some other brand. Which one am I using? I think... Oh, are these SanDisk? Yeah, the current ones that I'm trying out are these SanDisk Extreme Pro 64 gig cards. I haven't had any serious problems with those yet, but I also haven't been using them for as long. Oh, I guess I already formatted this. That's fine. Oh, interesting. So Jeru and K is asking, does Tuco chatter at the birds outside too? Very definitely. No, Tuco loves chirping at the birds. The birds outside, I mean, there are a couple different kinds. We get some like seagulls and stuff, but we tend to have these really big flocks of crows outside. At least I'm pretty sure they're crows and not like ravens or rooks or any of the other similar black, fluffy, smart birds. And Tuco really loves chirping at them. All right, anyway. So here's the work in progress. I really shouldn't be putting the coffee on that desk. There's a different place for the coffee. Yeah, so I've also tried a few different things to simplify this. The earlier version that you might have seen of this had a separate board on the side, which I was using for pulse width modulation, and now I'm doing all the PWM on the Raspberry Pi. So the Pi has... Oh, sorry, I should move this. I just noticed the microphone is like right in front of my mouth, so you're probably getting a lot of like puh and such. Hopefully that's a little better. So yeah, I'm doing all the PWM in the Raspberry Pi now. The pin 18 hardware PWM is driving the coil on this little transmitter. This tablet needs a signal at 255 kilohertz for it to work, but there are probably other models of tablet that use the same approach where the pen is just transmitting a sine wave and the tablet receives it. And on those other similar tablets, you could probably get the same approach to work just by changing the frequency. This particular setup is not resonant at all, so I'm not relying on the coil to oscillate at the right frequency. I'm just driving it, which is not very efficient, but it's easy, and so it makes a good tutorial. Oh yeah, and then Joseph is asking if I've thought about reusing the winches for kind of a hang printer deal. Maybe. My whole deal with the winches was not to really make them an accurate positioning platform, so I would expect it to have more like sag and bounce and stuff than you'd want in a 3D printer. Like it was really designed more for cameras where you want to move them slowly and have kind of flowing motions rather than just like following a tool path. But yeah, I mean, it might be interesting to see how well it works. It would certainly be easy enough to put like an LED or a pen or something on the end of the robot to see how well it can trace paths. This is indeed a very good cat. Also, the rug kind of makes an okay background for the DSLR frame there. Anyway, I was going to show quickly what the rigging points I was talking about are. So here's where we are now. This is what you're seeing. Then if you go up and up and up, so that's the wire for the camera, which goes up to the mount and then back down to the rack, which is over here. And then there's my desk where I do editing and organize files and wait for stuff to copy and do 3D models and all that stuff. So yeah, the ceiling is pretty high. I think it's like 30 feet. I did actually make an accurate estimate and then put that in a 3D model. I'm just forgetting that number off the top of my head. And so on this side, so part of what's weird about this is that we have this beam sticking out. The beam would be kind of a nice place to anchor it because that's actually pretty easy to get to. As you can see, I've already hung this fan off of the beam. I can get to that. It requires using a moderately big ladder, but I don't have to extend the ladder all the way. But it's not really as high as I'd want the robot to hang. Hanging the robot from that beam would require using more tension than I'd like to get the robot to an appropriate height. So it gets better mechanically if I can anchor the robot from a much higher point, which I can. So how much can I zoom up there? All right, so then there's all this stuff on the roof. There's a gas pipe, which hangs out kind of awkwardly in front of that roof truss. The roof truss itself would be a useful anchor point, kind of, except getting over there is actually kind of tricky because of that gas pipe. Those are the existing rigging points. They're actually C-clamps. It's not very good, but that's what I've got. Yeah, and I can't hang anything from the gas pipe. I can't hang anything from the fire sprinklers, both for safety reasons and because I don't want to get evicted. So over here, I think the best candidates are, if I want to go all the way to the ceiling, there are a couple of good metal beams. So there's that one right up against the window. There's that more structural looking one behind the window. And those, if I follow them all the way over, are clear. So if I have a good place to, a good way to climb up there, and I attach good quality clamps to those beams, I could rig from those. So that's one option. But that requires probably leaning the ladder on that close beam. So then it makes the far beam a little bit awkward to access, but doable. You just kind of have to reach through the ladder. The whole thing seems terrible. I'm getting like vertigo just thinking about it. So that's one option. Another option is this beam that's being used as a curtain rod right now. I think this actually originally was like a window opening beam for this warehouse, and now it's being repurposed as a curtain rod, or maybe I don't know, I need to get a better idea of like structurally what these things are actually attached to. But that's not amazingly structural, but it might be good enough for my lightweight robot. So maybe one option would be to loop a rope around that hang bracket, and then the pulley hangs out like a few inches from that rope. Oh, my autofocus is having trouble. Because these are big old heavy curtains, and that's not like just a curtain rod. I think it's originally a thing that was used for actuating the windows, and so it actually goes through the wall. So one potential problem with this is if I end up hanging a big old vibrating robot off of this, then it might transmit those vibrations into my neighbor's unit, and that wouldn't be good. So yeah, that beam seems like the best bet, but it's also very awkward to get to. So that's one annoyance. One thing I've thought about doing is actually just to do a temporary hookup where I attach it to something easy, like maybe even this little bracket here, and something over there. Just for temporary's sake, to get it rigged up to something in the meantime while we work on the real rigging. So I'm gonna try that soon, probably. Oh, sorry, the tracking algorithm doesn't know where I'm putting overlays over the screen. And then, let's see, how much of that can I show? I think we can show that. So then if we follow over, then there's this other area which has like a, so there's like a built-up loft on that side of the shop. And so there's a kitchen underneath, and all of that is under this platform that's roughly halfway up vertically. And then there's like desks and beds and stuff up there, but there are some rigging points, if I can get this right here. Yeah, so way up there, if the camera will focus on that. Thank goodness this lens has image stabilization. So that, I think some previous tenants were using this as a curtain rod, but where it's attached is actually pretty good. Like, it's got a C-clamp to that roof beam, and then there's a tension cable looped through another hanger, which I think is going into a stud in that. So actually, I don't know exactly what that's attached to. I was not under the impression that there was wood in that wall. I thought that was just drywall on top of the metal roof truss. So I'm not 100% sure that eye hook on the wall there is sturdy, but something in that vicinity is probably sturdy enough to anchor to. And there's a similar layout on the other side. Just follow this beam. And so this is, again, like at the full roof height, which is really annoying to get to normally. But because that's right next to the edge of the loft, like I can actually get to that with a reasonably sized ladder. It's not great, but it's easier. The other side is a little bit bad because there's, like, again, like gas pipes and stuff all over. Anyway, let me see if I can get Chuco again on the frame. James is asking if I can get a quadcopter up there to take pictures. I don't have anything that flies and has a camera on it. I guess those things are not that expensive these days, but I haven't really had a reason to own one. Maybe I could borrow one from somebody. Oh, where's the remote? I'm always leaving the robot remote control somewhere. Here it is. The gimbal's making unhappy noises because we still have not written code to correct for that. I do have a couple of like RC aircraft, like back when people just called them like RC copters. I've got a Blade CX2, which is like a really basic coaxial counter-rotating helicopter. It's a bit squirrely to fly, like there's nothing automatic about it, but it's like is a really inherently stable design, so there's that going for it. But because it's so inherently stable, you can't like really do a lot of tricks with it or anything. It's a little bit big to fly indoors, but it would work. I've also got a little one. It's also made by the E-Flight folks. It's the Blade MSR or something like that. It's more like a real helicopter with like a swash plate, and I guess what I'm saying is I have model helicopters but not multi-rotors. Sorry, I haven't joined the multi-rotor fad. But yeah, maybe there's someone around here that would like want to come over and take photos. That'd be cool. It'd be especially cool if you had a multi-rotor or some other device which would hold a Connect or something, but maybe I don't want that something that heavy flying around in here. Huh? Yeah, I gotta prioritize the cat, I agree. That was from a Yoshin YouTube chat. Alright, well, actually, speaking of the cat, one thing that I needed to do just to like bring this back to the topic of the stream a little bit, I was trying to develop this little wiggling robot to the point where I could make like an article and a write-up about it. And the whole point of it is kind of you have this very minimal robot that's capable of moving the pen around in some sort of random, sort of controlled, part of the trick of this project is to try to give it enough control that it can move the pen around and actually like reproduce an image of some sort. Have some noticeable intentionality to it, but it's still going to have enough randomness in it that that'll still come through a lot in the final results. So, I mean, I guess there are different ways to think about it. You could just think about this project as like, well, what is the best possible drawing I can get out of the simplest components? And so I guess that's one way to approach it, just going maximum fidelity. But then, I think even if you could get this thing to reproduce an image perfectly, I think the actual artifacts that you get when it's trying but not quite succeeding are extremely interesting. So yeah, I think maybe it's like slightly more than just the simpleness of it, but the way that it exposes the patterns inherent in a particular kind of randomness, and then shows you how you can shape those patterns. Again, Tuco's walking behind something, and I've left the remote control on the other side of the room. Oh, I guess the camera's fine. I still don't know where the remote is, but... Chuco's got this under control. I really just need to make this work with anything that's vaguely remote shaped. I keep like seeing the Steam controller out the corner of my eye, and it's like, no, that's similar, but not quite the same. I do actually have the app on my phone, which I could use. So I did not realize that you could just point your phone, at least this works in recent iOS, and I assume this is just a feature that OS vendors are going to start using. I'd been used to using a separate QR code reader, but apparently that's built into the camera app now, which is nice. So I can open the bot controller. Oh yeah, cool, and I point the camera app at it, and then it's like, open this thing in Safari. Does it fail to actually work? I think it failed to actually work. Maybe Maybe I should show this. Do I feel like bothering with the screen sharing just to show you a fail? Okay, I click the thing and it switches to Safari. Oh, maybe I just clicked it slightly wrong. It seems to be working now. Yeah, now I can steer the robot with my phone. How are we? Yeah, Chuco Flyer. Alright, yeah, so right before I started this stream, I was actually trying to find some wire to use for this bot. I think we made some pretty good progress on the last stream. So, just prior to the last stream, which was like late last night, I streamed when a lot of people were probably asleep. But I did a bunch of work off camera yesterday, and I got the software to a point where it's a lot easier to tell what's going on. So previously I'd been really like struggling to get any useful status out of this thing, because you would just run it and it would like printf a bunch of stuff, or like print a bunch of stuff to the screen, and then you get this directory full of thousands of PNG files that you could slowly open up and eventually get some information out of, which was annoying. The current state of things is slightly less annoying. So I was trying to balance this so that it's relatively easy to use and easy to tune, but I was trying to avoid a complicated software stack because I'm also trying to keep the software behind this as small and easy to understand as I can practically make it. So, I saw some options like, oh, you could use Qt, which is this full UI toolkit. Well, UI and a bunch of other things. It's like a whole application, like bento box thing. So you could use Qt, which is fine, but it seemed like it was like a really strange way of solving exactly one of the problems I was having, which was displaying the status images. And then, I ended up just kind of reimagining how that could work, and so instead the Python code, instead of just like dumping out a directory full of PNG files, it just immediately starts up a couple of background processes, one of which uses Pygame to display the most recent image, without like saving it to disk first. It just uses an inner process queue. And then another background process, which is actually FFmpeg, just starting up like a time-lapse video right away. So that has improved things greatly, and then I started building on that by just adding more debug info to those images. So it's still a little awkward in that all the debugging is being expressed via the RGB values of these images that are the same resolution as the input. And I could change that. I've thought about increasing the resolution, but I'm also just trying to conserve CPU time right now because, I don't want to have to make this code go through too many contortions to be fast, because I'm trying to keep it simple, but I do actually need it to run reasonably quickly, because if it takes too long to decide if the robot should change directions, then we're going to end up late for that direction change. So I think that's already a problem, and I might need some more optimization. Anyway, the thing I'm actually doing right now off camera, which maybe I should bring that over. I don't want to encourage him, but Chuco loves chewing on certain kinds of electrical cables, which is really bad. That's why a lot of the wires here are covered in that crinkly stuff. This is a box of damaged cables, most of which are his fault. And I was just pulling the insulation off of this extension cord that he had completely mangled. Anyway, I was looking for wire that I could harvest, since I don't think I actually have any really good thick spools of solid core wire, which would be the nice thing to use for legs on this vibrating robot. So I might have to improvise with something a little inappropriate. The best thing to use might just be multiple strands of the thickest solid core wire I have, which is like 20 gauge, but I wanted to go through this pile of destroyed cables to see if any of them were stiffer than that option. This was an extension cord that Chuco was just like chewing on for a long time. Not while it was plugged in. I've been quite vigilant about that, but it's interesting just to survey the damage to see how bad it was. And so he pretty heavily damaged the outer insulation in a lot of this. But there are a couple of pinholes where he did actually make it all the way to the conductors. So, like, if this was plugged in, he would have at least been getting a tingle off of some of these, which is not so good. So yeah, I try to be pretty vigilant about keeping him away from this stuff. But having a cord just like in a box that isn't plugged in for him to chew on didn't seem too harmful. The thing he actually does to kind of like take out his chewing urges on something that isn't wire is I let him chew on I've got these bungee cords that secure like extra chairs and tables to the wall, and they're only under a little bit of tension, and they're big and fluffy and full of rubber, and he loves chewing on them, which seems like an okay thing for me to let him do. So here's another cord. I don't know if this one's actually Chuco damaged. I think this was just an extra cord I had. Oh yeah, I should file this one differently. This one is not damaged. It's not damaged, it just doesn't have an end on it, which is fine. And a lot of these are thinner, completely useless for this purpose. Okay, then there's like this stuff. It's like dryer power cord kind of stuff. I think those individual strands are just too thin though. It's going to be too flexible. Yeah, I think the like 20 gauge or whatever is probably going to be my best bet currently. All of this stuff is designed to be really flexible. It's not what I want right now. I want stiff legs. Alright, so anyway, so the software improvements yesterday off stream, and then the stream pretty late yesterday, I was focused on, focused. It was not very focused, but I ended up working on the software a little bit more, and then building a new version of the robot out of paper to see how well that would work. And that was okay. That actually taught me some things that were useful. The robot didn't end up working very well, but that let me test like how important the legs were versus the motion of the pen nib. And I think actually the legs are super important. I got the impression that maybe they weren't from my original prototype because it didn't look like the legs needed to contact the ground very much. But I've got a theory which needs some testing, but I think maybe what was happening that caused the first robot to work when it did work was that the vibration would cause it to kind of alternate between positions where it was balanced on different combinations of the pin nib and one of the brushes. So, Alice is asking, what about the core of that coax? I didn't catch which coax you were talking about, but I think the only coax I'd have would be pretty thin. I know some coax has a stiff core, but I don't think I have any of that stuff handy. I used to hoard like television coax, but I got rid of most of my stash of that a long time ago. I've got like DVI cable, but that's just a bunch of little stuff. Yeah. Yep. Well, I've got some of this, I think this is like 20 gauge stranded. It feels stiff for stranded, but I think I've got some solid wire that would work better. If I make the whole robot really lightweight, I don't need the wire to be that stiff. It's just that the stuff I have is really not very stiff at all, and seems like I should get some different stuff next time. Well, I didn't like buy this for this project, but like I probably should buy some wire specifically for this. Okay. Yeah, so my theory was that it was kind of wobbling between different states. Maybe I should turn the DSLR back on so I can illustrate this. Gotta keep the servo AF, right? Oh, paper clips. Brilliant. That might actually be an improvement over what I've got. I know I have paper clips. What a great idea. Thank you. Haha. I'm also noticing I've got a bunch of like ancient dip ICs in roughly the same location I have the paper clips, which have stiff legs, but they're not nearly long enough. Yeah, thank you. Oh yeah, James is saying TV coax in the US usually has a stiff center because the center conductor is the pin of an F connector. Yeah, that's the stiff stuff I was thinking about, but I don't have very much of that. The small amount I do have, I have for specific reasons and wouldn't want to just tear it apart. Oh, this is perfect. Look at that. That's already my robot, basically. I want to attach the vibration motor probably to like this top leg maybe. And then, yeah, I mean, I can figure out exactly how I want to bend this, but I think what I want to do is attach the vibe motor to maybe this leg, have this be on the paper, and have this be around the pen. Something like that. Yeah. So yeah, anyway, I'm getting ahead of myself with the wires here. Part of I think what we were getting to yesterday was a better understanding of how the robot moves in the first place. So if I can maybe illustrate my theory. Right, so this has some control to it. Like, I was frustrated that you couldn't move the brushes around, that they're static. And I trimmed them a little bit with wire cutters just to get them to a length where they seem to have an effect that wasn't... Like, because I actually printed them with pretty long brushes, but they were just way too long. You couldn't actually get the pin nib to the paper. So I trimmed it to try to give myself more range for adjustment. So now you can move the nib... That's really hard to see. You can move the nib further in or further out in order to change the balance of the robot. So with the nib further in, then it seemed to work better, but it's harder to balance. With the nib further out, then it doesn't actually draw. So there's a sweet spot. So, but then I think what was actually happening was when the nib is further in, then it would tend to rattle around between different orientations. So right now you might notice it's sitting on like this brush and the nib. This brush is just up in the air. So I don't think it would be able to move that way at all. And I think that's part of why we're seeing these patterns of like two motion vectors and then not really a third. But then the pattern changes depending on how the wire drapes. So like if this is draping, well, you can see it changes the rotation too, but even if the rotation doesn't change, then just by changing where we are relative to where the wire drapes, you can see we're balancing it a little differently. So I think that was the root of both the function and the dysfunction we were seeing from this robot. That's why it worked, but only in two directions usually. And then, so yesterday I tried a couple variations of this with paper. There was one version where I just had like not much of a leg at all, just like something kind of resting on the surface. And that was like kind of alright. It was hard to control, so then I made some long legs out of folded paper that I could tape on at different angles, like this. So multiple of these on the ground. And that then gave me much better motion, because this is really how the BrushBot works. You have this symmetric vibration, which you then have an asymmetric linear motion that results because of this kind of angled leg or brush or whatever kind of squishing a little bit and then releasing energy. And so if you have the vibration without that little asymmetric energy release from the leg, then you'll hop around, but you won't actually move much. And so I think that was part of what was going on. So yeah, I tried these. These move a lot, but they don't really balance where you I think what I really want is to have kind of a weak spring connection between the leg and motor assembly and the pen, so that these move around on their own and then pull the pen without vibrating the rest of the assembly as much, maybe. But the main reason I want that weak connection is so that all the pieces can find their own balance. So that this balances on the ground, the other legs balance on the ground, and then the pen also has its own small amount of force on the ground. And so I could kind of start to do that with paper, but I think wire is where it's at, because I can just bend that and try to get about the right amount of force. So that's why I'm thinking maybe something like this, where the contact point can be close to the pen. That's fine. It just needs to be far enough away so that the pen doesn't fall over, so I can adjust that. The motor can be basically as far away as I care to put it, just on here. And then this might even want to be longer or more bendy, just so that it's coupled more loosely to the pen. I could even maybe use a rubber band to connect this to the pen instead of taping it, but tape is probably loose enough. James is wondering how much it would change the dynamics to have a wireless version. Yeah, maybe. That just makes the whole thing so much more complicated. It'd be interesting to try doing that on my own, but I don't think that's the thing I want to do for like a how-to. Yeah. So I think the next thing to do maybe is to just try taking apart the paper robot that we built last time and building these paper clips into the legs. So put that aside. And where is yesterday's robot? Oh, it's up here. Oh yeah, James suggests I want a rounded bit touching the paper so it doesn't grip too much. Maybe. My thought about the point was that it would be less likely to smear the ink. But yeah, that's like, we can definitely play with the shape of the paperclip end, for sure. If I had the app handy, I would actually make the camera slightly better framed. But it's in my pocket, so of course it's handy. Oh yeah. Okay, it is actually really nice just being able to launch this with the QR code and then have an app that controls the cat cam. Alright, let's take this apart. I was still trying to figure out how I want to do maybe the camera's a little too close. How I want to do the coil. It might still make sense to make that out of paper. To have a little tube you can just like stick the pen into. But we could decide that later. I've already got the paper tube, and I think I can use that independently of the legs. Carefully unwrap this around all the 32 gauge wire. What a good cat. Yes, Kyle says hi. Oh, I've got a question in Russian in the YouTube chat, but I cannot read it, I'm sorry. I'm a little busy to auto-translate it myself, but if you can translate it, I'll give it a shot. I know that doesn't really help unless... I guess if you don't know English but you're like still listening for the names of languages, maybe that helps, but otherwise it's probably not especially helpful. But if you can understand English and are just writing in Russian, then that's cool too. Then maybe maybe what I'm saying helps. Oh, oh, cool. Len translated it, and it's is this for the cat she's doing? That's a great question. I mean, everything is for the cat, right? That's why I work and pay rent and build things, and that's just like everything, right? But no, this particular robot is less cat related than the other robot. It's mostly a drawing robot. It's not really about the cat, so no, not really. Sorry. Anyway, thank you for the translation, and thanks for the question. Yeah, it would be useful to draw a picture of a cat. In fact, I think I have one of those. It's not very good, but it was good enough that I saved it. You know, baby's first cat picture. Something like that. That is so far the best cat picture the robot has drawn. I suspect there will be better ones in the future. It often draws stuff more like that. And now I'm taking it apart. So sad. I'm making it better though. Let's give it some more slack. Cool. Yeah, thanks for the question. That was fun. Carrick says, any minute now, Snake Eyes is going to wake up and run over to paw at Chuco on the screen. That seems like success, doesn't it? Oh no, there's like a rubber layer on top of these vibe motors that I'm pulling off as I take the tape off. That was probably important for people mounting these in a cell phone or something, but I don't care so much for this application. I should bring a trash can over for all this tape and paper I'm taking off. Whoa, my mic is so mobile. And anyone could broadcast if they knew what frequency this was and they'd had a truck parked outside. Actually, that'd be a great way to run a number station covertly. Although I guess you need to lock onto my carrier frequency. This is FM. You need to like covertly transmit something that doesn't add a lot of interference, but nudges the audio around enough to encode some covert signal in there. And then people can just download it over YouTube. And it ends up in all my backup disks and everything. You could also do that optically. Anybody who's recording video, you could just like shine some bright light in their window or something. And just something you can detect. So anything that gives you more than the noise floor. Doesn't even have to be above your camera's quantization threshold as long as it's above the noise floor, or at least like not too far below it. Why did I use such tiny wire? These are self-adhesive, which I find funny. I've not actually peeled the adhesive tabs off yet. Alright, so now we have a tube sized for the marker with the fake tablet pen i.e. 50 turns of wire wrapped around the end. And this is a little 5-wire wiring harness, which has a common wire that goes to the 3-volt, well, 5-volt now power supply, and then 1 wire for the coil and 1 wire for each of the 3 motors. Trying to slightly untangle all of this stuff. Alright. Man, this paper is very busy. Maybe let's have a slightly less busy background. Alright, so how are we doing this now? Is this still a good... am I still happy with this tube? That seems nice. Like that still holds snugly and allows you to balance the pen nib on the paper. Let's get 3 similar paper clips and build them, or bend them into 3 similar shapes. Oh, get some kind words from Palmoff on YouTube chat. He says this project is really cool from both a technical and a conceptual standpoint. Thanks. Yeah, I'm glad to finally give this a better shot. This was one that I found this idea really compelling a couple of years ago and didn't actually spend the time to develop it. Oh no, gimbal. Oh no, gimbal. Stop that, gimbal. Where did I put that remote control? Now I'm just dropping microphone parts. Can I just tilt this camera until it sees Chuco? Kind of. Well, it's not that unhappy anymore. Maybe now I can get my phone. Go up. Yeah, I don't know. The camera is great when it works, but the bugs are pretty annoying still. I suspect that's going to be the case for a little while. That's what I get for like developing stuff. What do we got on the debug output anyway? Speaking of debug output, what do we even have that connected to? We've reached the part of the show where I have to reconnect the right HDMI cable so that we can see the debug output of the robot. Yeah, why do we have 4 input HDMI switchers instead of 5 input? That would be slightly nicer. Actually, I think the proper solution is to get that Tandberg C90 working as a big ol' HDMI distribution thing. Because yeah, I don't know if you've been following that sort of line of streams, but that work has not made it into an edited video yet, but we got this really awesome donation of a bunch of really nice video conferencing gear. And part of the allure of that is that it has lots of inputs and lots of outputs, and we actually have 2 of them, and it might be nice to use at least one of those as a like a video crossbar switch compositor effects thing for the whole video stream, and that would be a nice upgrade to my 4 input HDMI switch. Yeah, the debugging is nice. Oh, nice. Alice loves the border. Yeah, actually, the boxy thing is usually disabled. Let me use my phone interface to disable that, if I haven't finished losing my phone Maybe I just lose anything that's being used as a remote control to control this robot. Maybe that's how it works. Pardon me while I look for my phone. Here it is. Okay, now I'm actually logged into the robot again. So we have layers, object detector outlines. There we go, I can just turn off some of these layers. The debug text is nice when I'm actually using it for debugging, but the little cat sprites are less wobbly because they're not trying to be like per frame debug information. They're just trying to give an indication of where the robot's paying attention to. So yeah, kind of the whole point of them is to smooth out the frame by frame variations and give it more of a sense of what the attention is. You can also see now there's a, can I point to it? It's like right there, kind of just to the right of Tuco's butt. There's a slight overlay with a blue X, and that's showing where the gimbal is relative to its limits. So it's pretty centered right now. And it's occasionally detecting Tuco's tail as part of his body, which is why the camera jerks down sometimes. And here I'm steering it around manually. The gimbal is not silent, but it also does not sound cranky, so I think we're alright for the moment. Now I'm going to lose my phone again. I'll have to put it next to my coffee so that at least I'll spill coffee on it first. Kyle says 70% cat, 30% zebra. Yeah, maybe I do miss the object detector labels. That stuff is nice to see sometimes. I should really share this UI that I'm seeing with all of you folks. Oh, I think that's the view we wanted. So yeah, we're not seeing the debug now, but now I've got the joystick. Joseph says, don't do what I've done and put your phone into your coffee instead of on the charger dock. That would be a fun gag gift, like a mug-shaped wireless charger, and you just put your phone into the mug and it's charging. Did you ever see those like fake water glasses that they'd have like a thin channel around the outside full of actual liquid, so you could make it look like it's a full like clear cup of coffee or something? Anyway, I don't know why anybody would need something like that, but if you need a bad idea, here's a bad idea. So yeah, this is currently how you adjust the overlay. And these are really hard to grab. Sometimes I hate phones. Gesture recognition. It would be nice if that was more customizable. Instead, they just expect the humans to adapt. Oh no. Get out of there. I should really just adjust. Whoa, Chuco, what the hell was that? Did you... Chuco. Okay, this is getting crazy. Chuco, why? Okay, whatever. Paper clips, right? Are these actually the same? I think they are. I think we can find one more of those. Hey, Chuco, please, you don't want to be chewing the multimeter probes. What is wrong with you? Oh my god, this cat. Heavy cat. Hey, boy. Usually my strategy is I'll just pick him up and then he'll just instantly want to go somewhere else, but then occasionally that fails and he actually just wants to hang out on my shoulder for a while. Okay. Well, I was gonna try to get 3 of the same kind. I don't think I need them to be exactly the same color. I was just slightly worried about that because some of the different colors here are actually like coated versus anodized, and that would definitely make a difference. But I think, yeah, why do I have colorful paper clips here and no standards, right? Now these all look close enough. So I've already got that one, and these seem like they go well with that one. Oh, that's never the sound I want to hear from my magic arm. Okay, so trash bucket. So 3 roughly similar paper clips. Yeah, I like that too. James says if the legs are different colors, then I can identify them now. Like the pink axis is not responding. Of course, then I'll have to keep up a mapping between which color goes to which I/O pin. But that doesn't seem too bad. I think the next thing I want to do is tape the motors onto each leg and then tape the legs onto the center tube. And then just see how well that works. So I think I still want them to be in this orientation. And in fact, so one potential problem is like if I just kind of tape it on right here, like imagine just like a little flag of tape around this and around the center here. That would be nice in that it lets me position it up and down here, but it would also tend to want to twist like that, which would change the motion I expect. So I'm thinking maybe I put it inside this little elbow. Maybe like that, so the wire is not going to short against anything. It seems like a relatively protected place for it too. But I can still bend the wires. Also, I keep using this like black masking tape for this. I don't want to like use up my whole roll of that stuff because I don't know if it's actually the best tape for this. Let me see what kind of tapes I have. Like I don't know what kind of tape I will recommend for people to use. I'll probably just say use your whatever tape you have, because I don't think it matters that much. I could use blue tape. It's not very sticky, but it might be good for prototyping. I also have duct tape. Duct tape robot has a nice sound to it, doesn't it? Maybe I'll use the blue tape for this particular prototype, but think about duct tape later. Alright, I'm going to cut some little rectangular pieces of tape. I do actually have non-stick scissors around here somewhere. I don't think I need that for masking tape, but for cutting foam tape, it's super useful, because that does actually stick to the scissors a lot otherwise. I'm just trying to cut 3 roughly equal pieces of rectangular blue tape here. And then it is super fun making stuff out of paper. I should really do this more. Alright. So then I'm going to put the motor kind of right up in this elbow. That's going to be pretty strong, I think. Something like that. And these all get kind of folded in like little packages. I might want to cut right there. A couple of cuts, actually. Sheesh. Let's not put my fingers in all of these. Let's see how well that worked. So I tried making one cut over here and then one cut over here. So the idea is, I should really zoom in more. That folds over like that, and I turn off autofocus, and this is the corresponding fold. And then that. Let's try to do the next one with less of my fingers taking up all the frame. Yeah, that's what I'm going for. Vibration motor, tape, leg. Easy to bend, but pretty sturdy, I hope. I think those are the right points to put the cuts. I'm trying not to cut through to the surface of my tablet. I'd usually recommend people use a cutting mat. This tablet's been through a lot. I'm not great to tablets that I hack on sometimes. I've got a nice Wacom Intuos that I actually use to draw on, but then I've also got a pile of like experiment tablets like this one. Most of them are Wacom CTE 450s because those are so cheap. I thought about using one of those for this project because those are really cheap, but they're also small. And this project, it's nice to have a bigger tablet. And this is the cheapest big tablet I know of. It's the not the Wacom, it's a Huion H610 Pro. And the cheapest I found them for is about $50. It ranges from like 50 up to like 80 depending on where and when you buy it. The prices for new and used are about the same from what I've seen. It's also very simple inside, so it's pretty inspiring to think about like, oh, what about, could we just do like an open source Arduino-based drawing tablet? Like that would be fun. A lot of the cost there would just be making the circuit board, because it's just a lot of square inches. Alright, got little leggy things, motor bits, and a tube widget. Alright. Yeah. I think I want to just put a piece of tape on over this. What I might do is use... This would be an interesting place to put elastic on instead of tape, actually. I might use some little pieces of tape to just secure this in about the right place, and then think about maybe some elastic. Just like ripping off pieces of tape now. This piece feels like it doesn't need to be as precise. Yeah, this is great. This is only a very rough positioning. This is going to need adjustment for sure. I think it's way too low at the moment. It's also kind of hard to keep them positioned just like that. Like, one way to keep these positioned would be like another piece of tape around in a triangle, or 3 small pieces of tape. Oh, I could also lay the paper clips down on the pen like that. That would actually make them a good bit easier to keep the angles sturdy. Yeah, let's do it that way. These pieces of temporary tape are not helping. Let's think about a different way to do that. Maybe just holding them all on? I don't know. A zip tie wouldn't actually have enough grip. Hair tie? I've been thinking about that, but I think it might be too grippy. Didn't I have like a hair tie over here somewhere? Anyway. That. Yeah, maybe I do just want to tape these down incrementally, but let's just try this part again. Let's try instead using a long piece of black tape. Let's also tape this a little higher up on the stem. We can do precise leveling, but I want to get that at about the same level I would expect the pen nib to be at. And then I'm going to actually wrap that on pretty tightly. And one more, two more. Okay, now I'm actually going to try to get this about even. I'm going for triangle here. Let's actually do that with a piece of tape in hand. That seems about right. So each of these is going to reinforce itself and the ones before it. And I'm just wrapping them all the way around the cylinder. And so the idea here is that whole loop of wire holds against the tape pretty strongly, but then I have this loop that I can adjust the leg position, and then this I can adjust to actually adjust the foot. Totally just winging it here, but I like the way this is going. Something like that. All right. Maybe I'll do one more complete wrap. Just trying to keep it kind of tensioned at every step as I wrap it on. And I can just press the ends of it. Okay, there's the weird robot so far. We have 3 legs that are all contacting the page, and it stands up. The tricky part is now, can I adjust it so that the 3 legs contact the page, as well as the pin nib? All 4 of those points should be on the page simultaneously. Alright, so I'm pushing it in pretty firmly. The pin nib is floating just a little above, and I'm going to try adjusting the legs. That looks about right. The pen is drawing all the legs are on the ground. Cool. Let's tape down the paper a little bit so it doesn't move around. I'm not going to give it a fresh paper yet, but the paper does need to be taped down because otherwise it spends a lot of the vibrational energy moving the paper when it doesn't need to be. Okay, let's try this out. This is the GitHub repo, by the way, scanlime/wiggler on GitHub. It is the worst drawing robot. Pen wiggler. I'll be adding more info there eventually, but right now it's just the source code, basically. Wesley is asking what kind of tape is that. I've been using two kinds of tape here, but I think they're basically just different kinds of like masking tape, blue and black masking tape. Oh, the power supply is not on. Let's turn the power supply on. Calm down. Okay. It had ramped up its PWM values quite high by the time I actually turned on the power. Let me let it. It'll settle down if I give it a minute. Well, I think it's got some balancing problems, and the PWM is just like way too up there. Let me restart it. If I restart it, it'll start out at 0. I think it's also just not balanced. They were really wobbly, and I don't want them to be part of the parts list, which is why I've been leaving these out, but I think temporarily I'm going to bring back the little scissor lift things. If I can find the third one. It's also possible I've already lost. Oh, here's the other one. Okay, I've got 3 still. These are not great by any means, but they, or at least some way to adjust the tablet height and level it. I also had a marble around here that I was using. Of course, marbles are actually not that round. I probably should be using a ball bearing, but I didn't have any big ones handy. The other thing I have is a level. Problem is the level is actually so heavy that it influences the leveling of this table. This is way worse than leveling my 3D printer. I think that's close enough. Let's find out. Took the ruler out of my level, and it's apparently actually pretty hard to get back in. can do that later. Anyway, let's start this. Should start slow. Maybe I need to decrease the voltage. Well, now it's having trouble going right. Looks like the feet are wobbling a little more chaotically than I would like. I'm gonna try turning down the voltage first. I think it's just got too much vibration. This is 3 volts. It's still just like way off over there. Let's work on the foot tension a little bit. Pliers. Let's get some additional pliers. Oh, that's a good question. James asks how heavy was the previous design. I haven't weighed either of these. They feel similar. I mean, I'm picking this up with the pen in there. What is that like without the pen? Wow. This feels like half the weight. It's probably not quite that dramatic, but I don't know if I have a scale that goes down this low. Okay, I'm going to try to bend this first of all so that the vibe motors are all in the right plane, so they're just like perpendicular to that axis that goes through the pen. Because they aren't quite sitting like that naturally because of the way I kind of wrapped them around, kind of with the paperclip tangent to the edge. So that involves a little bend in that direction. I don't know how much that matters, but I'm going to try to keep it level. And then, yeah, let's try curved feet. So I'm going out and then back. Okay, now those are all contacting the paper pretty solidly, and there seems to just barely be room for the pen. You must build additional pliers. So far I've not seen 3D printed plier designs that are especially good. What else could I build pliers out of? I've got like aluminum extrusion. This is me trying to level the pen tip again with these 3 feet. I want the pen to be just barely far enough down that it's actually writing. And there it's writing some of the time, which might be what we want. You are starting up fast, aren't you? I'm not actually printing out the PWM values right now. Wow, it's having a good stretch of staying in the lines, though. What are you doing, bot? You doing okay? See, now it ramped up the PWM for some reason. How do the vectors look? This might be a leveling problem. Okay, I don't know why it's so far to the left. It seems to have the ability to move in 3 directions now. We might need to take a closer look at these individual frames. Alright, here's a frame from what was just going on. So the robot was over here. It had some vectors over in this direction and over in this direction. Not clear why it didn't have any vectors going up. I mean, usually the reason for that would be the robot has rotated a bunch since it last tried those vectors. The robot does not seem to be rotating quickly right now. So maybe it just doesn't try those vectors very often. Anyway, it should be going this direction. Is it? It seems like it's going down and left a lot. These scores seem a little better. Maybe there's too much hysteresis. Let's bump the hysteresis down. If we increase the age modifier and decrease the hysteresis, we'll be trying to do a better job at accurately determining what vectors go where before just going with them. I mean, there are other factors that go into that too, but those are 2 that I think are relevant right now. Restart. Tomas says, I like how much quieter this is compared to the old one. Yeah, I mean, they all kind of depend on the voltage and like how much vibration you give them, but this one produces a lot of motion relative to the amount of vibration. It seems like what is that, the light purple foot is not contacting the ground as well as it could. Bend that one out a little more. Let's try that. Oh, the wire legs are so much nicer. I like this design so far. I like how the elbow there holds the motor nicely. I think it's having trouble with that direction now. We could also go back to the 3 vibration modes. I think that might be good for debugging purposes at least. I rearranged the code a little bit since the last stream. There's a separate init function for that, I think. Oh, maybe I need to pull the latest code. Oh, I'm gonna have a bunch of merge conflicts, aren't I? Let's do that change over again after I get the latest code, since that was a pretty simple change. That was hysteresis down and age modifier up. Okay, so in this Wigglebot class, there's now init modes, which is defining which vibration modes we want to try. This mode thing is like one particular way we can try moving in, and this changes whether we're defining those as single motors or combinations of motors. Or that was not what I wanted. Run the bot. I don't quite get what Shorty is saying. If the tube were a little larger, the weight of the pen would hold it against the paper without holding the feet off the paper. Oh, you mean if the pen could slide in the tube? Yeah, that might be a thing to try. Yeah, that was something else that was on my mind too. Like, could we make this slide in there? Can I do that without remaking this? Do I have any thinner pens I could try this with? Oh, I could try one of those mechanical pencils I like. I think those are thinner. These are the ones that just have a long pencil lead and a spring. So in fact, I can imagine something that if you wanted to do this with pencil, it could just have a long pencil lead with a weight on top. So that fits loosely. Oh, and it makes a nice soft mark, actually. That could be really interesting, especially if I've got the algorithm tuned to just like spend a long time wandering around and approximating the probability distribution of an image. That's a lot easier to do with something that doesn't leave such a thick black mark as one of these felt pens. Let's see what this does. We're not getting any down vectors, are we? The directionality of the motion is not amazingly decisive, but The sliding pen tube is definitely a good idea. I like where this is going. I'm kind of wondering if it would be better with like a pointier tip on the legs. I think part of the trouble with a pointy tip is it would probably be really sensitive to the exact direction of that point, but maybe that's a thing that's worth tuning. How are we doing though? We're kind of staying in the line. Let's see how it recovers if I just put it over here. I guess I dropped it pretty close to the circle anyway. Yeah, I like the way Gordy's thinking. The statistical buildup of the pencil. I think we're on the same page. This pencil line is very light, but it's definitely there. It's like hanging off just a little bit off the edge though. Like maybe it just found a... Like, is that actually uneven because of the ink? Doesn't feel like it. Let's play with the foot shape. I don't think this foot shape is working for us. Yeah, I could get softer lead. I think this is the only kind of this particular mechanical pencil, but especially if it's not going to go through the pencil that quickly, I could just put a soft lead pencil in there. Let's see what I've got. Oh, I've got more of those. That's right, I've got more of these. I think they're the same, just different colors. It might be interesting to give it a less cluttered page to write on to see what this is going to look like. Maybe even a blank page if I dare. 4B. That's pretty soft, right? Does this fit real pencils? Of course. Oh man, I love the tube. It's still not drawing very well, but this is a step in the right direction. Alright, let's turn this off and bend the feet. I'm just going to take that same bend and just angle it toward the paper so we've got a little, just like a little point that digs right into the page. I should also make sure the vibration motors are actually in the right plane, because if they're not, then this is going to be unreliable. It's also possible I want the foot to just be shorter to put the motor closer to the foot. Also, I don't know if this tape is actually the best way to hold the motor on. I wonder if this is absorbing some of the vibration. It feels like it should be strong in the right axis, but I'm not super confident about that. The only reason that tube has to be as far down as it is now is to provide a good place to wind the coil. Let's see what that does. See, I think the digging into the page is good because that makes the feet that aren't vibrating act as an anchor, so you get more like differentiality in like what directions you can move by activating the vibration. At least that's what I would hope for. That's interesting. We're getting kind of a repeating pattern with those vectors. It keeps stopping because it gets a short vector that's in the wrong direction, but then it comes back to it because I wonder if that's a problem I could solve with longer time steps. It also just is not getting any top left vectors. I think the foot knee is more of a point, actually. This is close. It's getting there. Sandpaper sandals, that would be funny. Maybe it would be easier to see what's going on if I gave this significantly longer time steps for a sec. And it's not really moving very well in any direction right now. I'm gonna make the feet shorter. With wire cutters, wherever I put those. Oh. Doesn't need to be very short, does it? As I still want all of this isolation between that vibrator and the central portion, I think. Spidery legs. Oh. I need to tune these so they rotate less, but they're definitely moving. How is this doing? This seems nice. Let's see if we can put the time step back where it was. Now let's just revert all that. Try the settings I had as of earlier today. So we're back to combined modes, we're back to shorter time steps. A little more complicated, but still should be working basically the same. No, that actually might be a problem with the combined modes or with the new time step. Okay, let's turn that back off. Let's first turn off the combined modes, leaving everything else. Yeah, I think the one motor so far might be better. I'm still going back and forth about which one is actually better, but that's why there's an option in the software, because I haven't decided yet. Hello? There we go. It's actually sending these images over Wi-Fi, and the Wi-Fi is not very good here. Let's give it longer time steps too. Oh, thank you. Jordy caught the problem that one foot is catching on the edge of the paper. I should just go back to using a large piece of paper. Now it sounds very slow and methodical. Okay, can we... Was 1/8 of a second what I was using before? Yeah. What about 1/8 of a second and single motors? Oh, that seems better. Okay, let me get a fresh piece of paper. Fresher. Are any of these fresh enough? I've got some that only have like some bleed through on one side. Let's try that. And this pencil is really, really faint. Oh, I'm like pressing on these and probably messing up the leveling too. It looks pretty cool. A little spider thing. The wide base is a bit of a problem. It does make it more likely that it catches on the edge of the paper if it gets anywhere near the edge, which limits how big of a thing you can draw effectively. So I might try making a less wide version of this next. All right. Oh, that's a nice idea from Jimbo, who says to cut the pencil down and then add a little bit of blue tack on the top for weight to reduce the center of gravity. That could be nice. Seems to be not going left much. Is it leveling or is it something else? It's not really getting a good left vector. It's kind of got one that goes almost perpendicular to the ring. At least I think that's what's going on. I just cranked down the left side a smidgen. See, this is one of those cases where I thought the combined modes might have been helping, because I don't think it has a good single direction it can go in. Maybe if I twist this pen a little bit. Of course, by taking it off the tablet, it ramps up the PWM. No, what are you doing? None of that is right. Maybe it was easier to see what was going on with the longer time step. Half a second. Super slow mode. James is asking if it can avoid the edges. So there is no path planner. That's not really what it's doing. It's not what this is about. And it is trying to avoid drawing on the. I mean, it's kind of more complicated than that, though. Like, it's not just about avoiding it. It's like avoiding it the right amount in relation to everything else that it's considering. I think ultimately the problem here is that it just doesn't have a lot of control over which motions are available to it because of the physical construction of the robot right now. Because like right now, it knows that like this is not a good place. It knows that left down is much better than going other directions. It just doesn't get that opportunity very much. And when it does, it tries it and it turns out to not be very good in the long term. Like that's what this graph is showing me. So it gets a bunch of other vectors that are no good. It eventually gets the chance to try one that it thinks is going to go bottom left, but then it actually measures it and it's like okay, but not great. And now it's way up there. Like, usually when you're seeing it go past the edge, it's not because it doesn't know where the edge is, it's just because it doesn't have the ability to not go past the edge. And I think I need to adjust the foot shape some more. Yeah, Gordy is asking how it knows which direction it's facing. It doesn't really know. It has an estimate of where it expects a particular motor to push it. But that's really a combination of a lot of factors, including, exactly how the legs are shaped and where the robot is leaning potentially and how it's rotating. So instead of trying to model any of that, it just tries to test periodically to see what direction it will go in and save its estimates for later. I don't know if this is actually a problem, but I'm wondering if maybe the area around the joint just isn't stiff enough currently. I'm gonna try adding another piece of tape. They aren't quite all the same, but I think they're close enough. So all the feet now are doing this thing where they slightly pull the robot in their direction, which I think is good. This one doesn't quite have enough push. The line it's drawing is almost invisible. Gordy asks if I think the motor is moving independent of the foot. I mean, slightly, but I'm trying to reduce that as much as possible. Let's see if we can speed this up. That's nicer so far. How long will it take to disappoint me this time? I mean, it's nice that it seems to have 3 pretty independent ways of moving, and the rate at which it rotates during motion is slow. That's like what we want out of the mechanical parts of this bot. Do I have thinner pens I could try? This pencil is drawing a little too slow for my tastes. Here's a different pencil that's just sharper. There's a calligraphy marker. I think that whole thing is too wide. Here's a ballpoint. I would not expect that to work. These gel ballpoints are kind of cool though. Actually, what would this do with a ballpoint pen? I'm curious. Oh. That's a little... It doesn't actually slide freely in this tube. And it doesn't really write at all. Alright. Oh, calm down, little guy. Okay, let's... This is just all over the place now. Here, I'm also curious what would happen if I just put just an unsharpened graphite stick in here. It'll probably end up like leveling itself out slightly. The one that was barely drawing at all was the 4B pencil. BFX666 says, what about creating a calibration procedure that confirms all the legs work fine? And yeah, no, that'd be great to do eventually. Like this is still in the R&D phase where I'm still trying to figure out what actually matters and what doesn't, but like that, having a tool would certainly be, or like a tool or a procedure or something is certainly something I want. Acting like the change direction delay is too big. Man, I wonder how much of what I'm seeing here is just bad Wi-Fi. So the frames are coming out on my console at a really inconsistent rate. This is kind of interesting though. Like, it's drawing a bit more than it was with the 4B pencil. Gordy's also looking for a way out of the self-adjusting PWM. I don't know, man. I like the self-adjusting PWM. I think it has some cool side effects. It means that the robot tends to unstuck itself if it gets stuck in a tear in the page or something. Most importantly, I think it means that this can be battery powered, and as the batteries run down, it corrects for that automatically. It sure is like not quite on the line. So why doesn't it stick with those up vectors very long? Because they aren't actually right. They turn out to be the wrong vector. Why is that? Maybe I need to turn the speed down again so we can actually see what's going on. There might just be something still that is like a speed-dependent bug. Like, I might just be... Well, there's a lot like I could be doing to pay more attention to the timing of like when the bot is actually changing directions versus when I'm performing a measurement. And so I might need to record some time series data and see like what the problems there are and what kinds of fixes I need. Like, it might just be nice to have this dump a CSV file out with its state on every time step, and then I can just graph that later. I'm going to plug this into the wired network, because this is definitely the Wi-Fi being flaky. Gordy asks if I think the motor fields are affecting the position coil. No. There's pretty much zero possibility of that. Completely different frequencies they're operating at. The kinds of things that affect the position, like, you'll see much greater effects from just like small differences in the angle of the robot and things like that. I need to change this. I don't think I have much in the known hosts file on this machine. Somebody who is previously using that same IP address was not the same host. Okay, that's a little nicer. Let's, I think I had already set that to 1/4 second. It's still having the same problem. Oh, can we slow it down even more? 1 second per step. I might need to change the age-related modifiers. It's a little hard to tell if that's what's going on at this particular rate because it's so slow. Not actually printing out the age-related modifiers. That's how it kind of artificially bumps up the score of vectors it hasn't tried recently so that it doesn't let them stay stale. But just to rule out a couple of these, let's set the hysteresis to 1, which is a no-op, and the age modifier to 0, which is also a no-op. So we should just see it try a direction. I mean, With that age modifier set to 0, the vectors can be stale for an arbitrarily long amount of time. Okay, see, now I just want to know, why are these mode changes happening? Okay, let's put it over here. With a frame rate this low, it also pretty much never accelerates, so it's going really slowly. Yeah, good job. So what was that about? Gosh, there's so many things going wrong that it's hard to focus on just one to debug. I need to print out more information on each frame. Let's also show the PWM values. And that frame rate was actually too slow to be useful. So let's go at least like 2 or 4 frames or so per second. As far as I can tell, the tablet position feedback is working really well. The reason I can tell that is that the line that it's tracing out here on the window is a really good match for what I see on the paper when I have a pen here. So I have no reason to believe that there's a problem with the tablet part of this right now. I have a feeling that a lot of the remaining issues at this point are related to time. Like, I probably just need to go through this code and be much more rigorous about which time intervals I'm measuring and then how I bill those back to different vibration modes. Because it's all just like kind of sloppy and involves a lot of delays right now. And I think what I need to do is do some tests where I do some example switches between modes and then like watch what I actually get out of the tablet data and like watch how it moves, and maybe even do something adaptively where like I think I probably want to change this so that the frame rate of my Python code is locked to the tablet's hardware HID report rate. So I do some processing that's associated with every single tablet measurement. So that's one thing I want to change, and just try to have my own loop that locks onto that. One way I can do that is to actually, so like I could actually use the tablet events to instigate all of my processing. I'm not currently guaranteed to get a tablet event every time it could send a tablet event. If the coordinate is exactly the same, it won't send it, which sometimes happens. But I could work around that by alternating my tablet pressure a lot. So like right now it's simulating no pressure at all, like it's simulating an idle pen. But I could change it so that it simulates a continuously varying pen pressure, and then I can just do some processing every time I get a packet from the tablet. So yeah, that's one thing I might want to change. And then just be doing some processing every frame, but choose during that frame. Like I want to categorize motions and be like, well, am I in between vibration modes? Is this a solid estimate for a particular mode? You know, that kind of thing. And then if it is a good estimate, then feed that into like a median filter or something over time, so that I get a better estimate that isn't immediately going to change as soon as I have a little vibration that's the wrong direction. That's a good question from Paul in YouTube chat, who asks, if you wanted this guy to work on other surfaces, could you use a vision system to track the position, like OpenCV, a PyCam, an LED, or an optical mouse sensor, suggests Gordy. Yeah, as Tomas said, it's definitely possible. You could even just like pick the brightest pixel. Yeah, I agree. It would be easy to use. It wouldn't be as accurate as the tablet for small surfaces, but if you wanted to try to use this on a really large surface, then you could definitely do it that way. For a large surface, you'd also probably have problems with the wire in this setup. A couple of people have suggested wireless versions of this with like battery power and maybe like a microcontroller to receive information. Somebody even suggested using a fan to blow the vibration bot around. I like that idea a lot. One thing I thought of, which I mentioned in like the first stream I did, but we haven't actually tried, is to have the vibration bot just vibrate without any feedback, but then have servo motors that tip the tablet a little bit. You could even just have the servo horn like stuck under the leg of each side of the tablet to just lift it a little bit, and then you could use that feedback. There's a lot of ways you could have variations of this to work on like larger surfaces, or use vision instead of the tablet. Yeah, you could probably have a version of this that uses an IR LED on the top of the pen. There's also ultrasonic. Like there were these ultrasonic whiteboard markers I looked at a while ago on my video blog, and something like that might work too. Have a little ultrasonic transmitter and then receivers stationed around the perimeter of your workspace. As you can see, it's not actually doing very well right now. If it finds a direction and sticks with it, then that's cool, but I think a lot of what this is doing so far is having kind of a false start when the direction it thinks it's going to get isn't actually right. And I mean, that's going to be exacerbated right now because I have that aging feature where it randomly tries, well, not randomly, but stochastically and semi-systematically tries vectors that it hasn't tried in a while to get updated values. So anyway, I think I'm running out of stuff that's like imminently streamable for this. This has been really instructive, and I think I've learned a lot about what to expect from the robot and from the software. I'm pretty happy with the robot so far. Let's get a closer look at how the legs are working. It's not perfect. There's definitely room to improve the shape of the feet, I think. But it does seem like it has at least 3 degrees of freedom here, which is all I can ask for, literally. So, also, a lot of people have suggested throwing machine learning at this problem in one way or another. Usually those same people don't have a lot to say when I ask them about the specifics, but like I have been thinking about that, and part of what's going on in my head here is that if you want a machine learning system to say, like optimize the parameters of this robot's dynamics, then you need some system for it to optimize. And if you're talking, oh, I'm sorry, getting the microphone tangled on the camera. And it isn't necessarily true. Like, you could design something where, like, a neural network just controls the whole thing. Like, the inputs to the neural network could be the tablet positions, and the output could be which motors are turned on. But for that to have any help of working, you need the neural network to have an architecture which then has a lot of the same constraints and problems to solve as the control system that I'm designing right here. So, like, I kind of see that as a problem that's a little bit further down the road, where if I can't necessarily get the results I want out of a pretty straightforward control system that I'm tuning myself, then I use these investigations to get an idea of what types of feedback and what types of optimization are important for the system, and then kind of create an architecture that allows a machine learning algorithm like backpropagation or genetic algorithms or whatever to actually tune those parameters such that it gives me the effect I want. And backpropagation is probably more like what I want for this, because, you know, people have suggested genetic algorithms, and it's like, well, great, what are you going to do? Like, replicate this entire robot and just, like, try the whole thing, and then just, because, like, you could do that, it's just, like, extremely inefficient. You want a system where the robot can learn online from the feedback that it's getting. And anyway, like, a lot of these things are just, like different approaches to the same problem, and you can even make arguments that they're mathematically really similar structures. So I think the first thing to do is just to figure out, like, what I'm actually trying to control with the robot and what kind of control system works. The current sort of raycasting control system is kind of nice, and it seems to sort of be working. And if I wanted to make a machine learning version of that, I could imagine having convolutional layers which work based on the, like, maybe what I want to do is have some image that tracks feedback state. Like, I probably want to have something that exists outside the neural network, which is just a system that tries to approximate what's already on the paper, which is probably just going to be drawing on an image, maybe doing some post-processing, but mostly just drawing on an image. So then maybe that image is one of the inputs to the neural network, and then there are convolutional layers attached to that. I'd probably want to center that image on the current pen location, so the neural network is then getting this view of, like, well, what's around the pen, and how bright are those areas, that kind of thing. The neural network probably also wants to get a similarly centered image of what the goal image is. But now, like, well, okay, what if I wanted to replicate this decision making based on that? You've got to have some kind of memory element that can store what the hidden state of this robot is. Right now, those vectors you're seeing across the screen, that's my memory. That's what my algorithm thinks is likely to happen if it tries a particular motor. And any kind of machine learning is going to need, ideally, a much richer representation, you know, something that solves the same problem but much better. So, yeah, like, what is that? Is that something that's encoded with a bunch of hidden layers of neurons? If so, like, what is the structure? Is it one-dimensional? Is it two-dimensional? Like, how do you encode the vectors? There's a lot of little questions to answer, right? Gordy says you could have it move in each direction in order and then just go longer when it goes in the right direction. That is equivalent to what it's doing. I mean, when I don't have that parameter set to 0, like I do now, but when I have that age parameter set to a non-zero value, that's basically the same as what it's doing. It calculates a score indicating how good the directions are, but then that score ends up getting skewed toward a favorable value the longer you haven't gone in that direction. So it's basically like a delta sigma modulator. Can you elaborate on that, Marcel? I'm reading a comment on the GitterChat, and Marcel says, speaking of neural networks, your input should be a vector, and output, your motor control, the actual transition vector would be the feedback. I don't really understand what you mean by that. Your inputs should be a vector. So, like, stepping back a second, my input to this entire system is a piece of paper, a PNG file. the output for the entire system is all the data I'm getting from the tablet and a piece of paper with marks on it. So everything has to fit inside that, basically. But the neural network, like, what does the neural network do with a piece of paper? Obviously, you have to have something other than a neural network, because the neural network by itself doesn't know how to do anything with a piece of paper. So we need a robot. Great. We also need something that simulates the robot's interaction with the world. So you can choose some amount of that to be in the neural network, but I guess I don't really see how or why you would implement like the entire thing in a neural network. So Ryan is asking if I used multiple coils, might I be able to switch them quickly and get the rotational position? Yeah. Switching them quickly is a little bit less good than it might appear to be, because these tablets don't scan the entire surface on every HID report. They get an idea of where the pen is from the previous frame, and then they're only usually scanning like 8 coils or so, rather than like a matrix of 32 by 32. So that would work if the 2 coils were pretty close together and you could synchronize them really well with the tablet scanning cycle, but it would probably mean that you cut your HID report rate in your effective rate at which you can scan the position by a factor of more than 2, because you'd have some cycles where you're waiting for that switchover unless you can exactly synchronize it with when the tablet is scanning, which is hard to do when that's not even completely well coupled to the USB HID report rate. There are tablets that just include rotation sensing as part of what they do. I haven't looked at how those work. Those would probably... I think they rely on having the pen tilted, so if the pen is perfectly 90 degrees, I don't think those give you good data. I think my Intuos Pro gives you a little bit of info like that, but from what I've looked at, it's not very accurate. I think the nicer tablets might have additional coils for that, but I'm not sure. Yeah, it gets off into the weeds pretty frequently, but when it's not messing up, it actually occasionally does the right thing. I think we're basically in the territory here where the robot is mostly working, and I'm back to dealing with software bugs. So I think the thing to do next is take a step back from just debugging the behavior we're seeing, and maybe do some simpler tests where I try to, first of all, I try to synchronize with the tablet's report rate. Second of all, I try to, it'd be nice, for example, so let's say I sync with the tablet's report rate. I think that's something like 100 times a second. So now I have a rate, now I have a loop in Python that's getting vectors at 100 times a second that represent a period in time that's pretty well known. So maybe it's not like the last 100th of a second. Maybe it's like a period from like 200ths of a second ago back to 100th of a second ago. Once I know that kind of information, I can start to correlate like when was that motion relative to that change in motor status. And then I basically just need to come up with a reliable way of taking some motion that I'm recording and then mapping that back to which motors were activated while that motion was happening, and then use that to update my estimates. So I think that's basically what I want. I don't like that strategy. Marcel is recommending dividing this into a separate problem where you pick a vector that you want to go in, and then you pick a way of using the motors to create that vector. I don't think that's ever going to be that successful. The whole point of this is that I have very constrained mobility in the robot. So, like, let's say I want the robot to go like that direction. It just can't do that. That's not a direction the robot can go in. The robot has like at most 3 different directions it can go in at any given time. And so I think it's a lot more useful to take those directions and then figure out what you can do with them, rather than just like in this ideal world where you can go in any direction, what direction do you want to go in? I don't think that's super useful. And then if I was implementing it like you're describing, where I have a neural network where I give it a direction and then it tries to come up with PWM values that go in that direction. So you've still got that memory problem. How do you store history? Like, what is your neural network architecture? I think it's still like you're just kind of kicking the can down the road. I think you still got fundamentally the same problems. It just has to be neural network shaped. I can imagine something like a long short-term memory kind of network working, but like that would require a bunch of experimentation. It is tempting to leave this running for a while, even though it's clearly buggy, and I need to spend some time just debugging the software. It does seem like, at least with this stick of charcoal, it might give me an interesting probability distribution. What is my timing right now? Yeah, see, my steps are very coarse right now, a quarter second. Which I think is long enough to hide whatever bugs I have in my timing, but also long enough that I can't really avoid leaving the lines. Like, if it's on a course to leave, then I'm not making decisions very frequently. Every time you see a line here in the terminal, that's when it's making a decision. It's not very frequent. So I think that's the thing that I need to fix pretty quickly. Marcel says it would be interesting to see if a network would find a perfect strategy to move it straight forward in one direction. Why? Why would you want it to try to go in one direction, though? Because then, like, how would you use that to draw your image? It's like now you have to keep changing what that estimate is on every frame, in which case I don't know that you would actually see that as a separate behavior. You'd end up seeing the combination of it trying to follow this vector and then the vector changing. Somewhat like an inverted pendulum, I guess. Paul in YouTube chat suggests perhaps a state machine. I mean, that's a very vague suggestion. I think what I'm going to need to do to fix this timing problem is probably to, first of all, just run some experiments to see what I'm actually working with. But I suspect that the fix is going to look something like, I'm just realizing, I don't know if this lump that I'm playing with is blue tack or eraser. I think it's an eraser, but it's very sticky. Maybe it's blue tack. Yeah, I just need to figure out like what I'm dealing with. Like, how long does it take for the pen to stabilize after I change the vibration mode? How much lag is there in the input device? How well can I synchronize? If I'm random, like how frequently could I change directions and still be able to get any measurements that are accurate? So those are the kinds of questions that I want to be able to answer. Especially that last one, because that kind of changes the rate that I can do my direction changes at. Like, if the system is changing directions too fast, then I don't get a good estimate of where I would actually go given any of those motors just being left on. And that's like a core part of the problem right now, is that those estimates are not very good. So yeah, I think I might wrap up this stream for now and let this run a little bit while I prepare the next software experiments. But yeah, depending on how that goes, I might I might have the energy to do a bit more on this today, but I will, of course, keep folks up to date on Twitter and Gitter whenever this seems like it might be getting interesting again. But yeah, these streams often run pretty long, but I think that often happens when I have this open-ended problem that I can keep working on. I think this one I just need to take a step back from it and write some separate little experiments, which might be good to do in a slightly different frame of mind. It's interesting that, I don't know, the way it's just hanging out over there. Ryan says, since the cable influences the behavior, you'd have to model that too. Yeah, for like a full simulation, for sure. It seems like in this robot design, the cable is influencing the behavior a little bit less, but still quite a bit. The charcoal stick in there is pretty cool, though. I have to say, I didn't anticipate trying that, and it's an interesting look. What'll it do if I kind of stick it over here? Ooh, it's not really under control, is it? It's just like... It also behaves a little differently depending on how hard it's trying to avoid overdraw. Right now it is not trying very hard to avoid overdraw. But, for example, if it was, then at some point it would just get tired of drawing over the same spot and it would start kind of going crazy, like outside the lines, just trying to kind of loop back around and get into other parts of the drawing. I've had some modes where it would get really averse to the overdraw, but then it would just end up kind of bouncing around between that area that it was drawn to anyway and the edge of the tablet, because I also had a severe, like, don't fall off the page bias that I applied. Yeah. All right. I think I'm going to wrap this up for now, but thanks for joining me. And as always, a special thanks to everyone who hangs out and supports the stream via Patreon or via sending in hardware or telling your friends or just putting up with all my strange robots. It's pretty good. Oh, Gordy is asking, is it trying to draw the circle or fill it? It's trying to draw just the like light blue parts. Is what it's trying to fill in here. But yeah. And I mentioned this earlier, but in case you want to check out the source code or try this yourself or anything like that, I'm trying to develop this into the point where it's easy for anybody to build, but if you want to jump in early and just like see what I've got, it's on github.com/scanlime/wiggler. You can find the pen wiggler, which is mostly just this single Python file. And it runs on a Raspberry Pi 2 or 3, with some transistors and vibrator motors, and that's about it. I'm using these little disc-shaped vibration motors from Adafruit, the Adafruit 30-gauge silicone wire, Raspberry Pi, and some of these TIP 120 Darlington transistors, which are way overkill for it, but it's just what I had handy. So that's what we got. Cordy says maybe make it a little thicker. Oh, making the circle that is drawing thicker. Oh, yeah, I guess. Although, it's definitely capable of drawing stuff this accurately. It's just not working very well right now. part of why I mean, I understand that this is one of those projects where I think if you just randomly tuned into this, you'd be wondering, like, why is she still working on this? This looks so dumb. Because it's really good at working badly. It's really good at that. But it also occasionally works really well, which I realize that many of you have not actually seen it work well, but it does. Oops. It does occasionally draw stuff that is kind of what I wanted it to draw. This is blurry, but it drew a picture of Chuco, which was very blurry, but kind of what it was going for. I'm pretty sure I can do a lot better than that, but it's what I've got so far. This is still the best one, which this one was on flimsy paper, which I don't know how much of an effect that had. I also babysat this one a little bit, where if it was getting too dark in one spot, I would move it to a different spot. You can still see it wore through the paper right there, but this was still pretty good. I've got a few... It's not very good at staying on the page right now. I've just got a few other attempts at the same image. There's another one that worked all right. This was a slightly different version of that with the sans serif. I've got a few of those. Here's another sans serif. So, you know, it's not great by any means, but it's giving me hope that it could be really cool. So I'm going at it still. Yeah, soggy paper. Yeah, I agree the charcoal is pretty cool. I'm going to keep experimenting with the charcoal. I think that's a really good idea. I might even try sharpening the charcoal a little bit, because right now it's completely blunt, which is not necessarily what I want. Oh yeah, no, I appreciate the ideas, thanks. I know I don't follow everyone's suggestion, because I think I'd drive myself completely nuts if I tried to, but I really appreciate them, and I try to follow a lot of them. With the really long frame rate here, it's just easy for it to go completely off the rails. Anyway, I'll let this run until it falls off some more and I get tired of babysitting it. And I'll do some software experiments and get back to you all with that. See you all next time.